Kennesaw State University, IT Capstone Project Number 2. Team members are Ashton Moore, Debbie Leiva, Taylor Gordon, J.J. Jones, Shakir Gilkes. Our project sponsor is Dr. Shirley Tion, and the instructor is Dr. Ming Yang. Due to the record high numbers of students and capstone projects, the current process of assigning capstone groups has become challenging for instructors. Instructors spend a lot of time trying to put students in groups based off their project preferences. This doesn't always work out in everyone's favor, and not everyone is happy with the results with the current selection assignment process. To solve this issue, Kennesaw State University wants a web app that will streamline the selection process. In order for this to work, the usage of a selection algorithm is required. KSU also wishes to use this algorithm for more complex tasks later. This web app has to be accessible regardless of the student's or instructor's location. Our solution to this is deploying the web app to a web hosting service. Our project sponsor requested that the web app be deployed to Microsoft Azure, since KSU uses this tool for other programs and would allow for a seamless integration into already existing applications. Our team had a total of 5 team members. At our first team meeting, we determined who was going to do what for the project. We also determined that we needed a project team leader, 3 developers, 2 database technicians, and 2 testers. To fill these needs, some team members decided to double up on what they were going to do for the project. By the end of the meeting, we came to the conclusion that the positions would be as followed: Ashton Moore, project team lead, developer, web app tester; Taylor Gordon, developer; Shakir Gilkes, database technician; Debbie Leiva, developer; J.J. Jones, database technician, web app tester. This project was broken up into 3 major milestones. Our first milestone was the initial database function and code review. During this milestone, we collected the previous group's code for review and testing. We made sure the code worked locally and fixed any bugs as they came up. The database code was also tested locally and fixed. We then prepared the database for deployment to our Microsoft Azure MySQL and web app instances.
Our second milestone goals were to start the website and deploy it to Microsoft Azure. To have the website store and process data, we also needed to deploy the database that was created for milestone 1. After both the website and database were deployed, it was necessary to link them together. Now, with an officially developed web service, there were bound to be bugs, so we began hunting for them. Some of the found bugs and fixes will be listed later in the presentation. Finally, our third milestone was to polish the existing product that we had created and also provide documentation for the next team. During the polishing process, we found more bugs and also tested some niche scenarios to minimize problems that will occur during real-world use. Because this project is designed to work in conjunction with other services, it was important that we had well-commented code and also some form of description of how the existing service was deployed, so that the next team to build off of our part of the project may be successful as well. The algorithm utilized for the web application environment is the Hungarian Monkrez algorithm, which was created by Harold Kuhn. Modern computers can handle this algorithm pretty easily, and our final implementation of this algorithm computes in under a second. This algorithm was originally designed to assign workers to projects and automatically reduce costs due to worker assignment. We were able to port this over to our specific use scenario in which students have projects to choose from. Each student can assign a cost value to each project, and the algorithm will place students into projects while also reducing cost. In this method, students are put into projects that they would rather be a part of instead of randomly. We believe that this algorithm is the best algorithm for this project, as it was designed for tasks that are similar to this project and can also handle large numbers of project assignments and selections. Next, we have a weighted numeric scale called the Dodal-Borda score. After all students have assigned cost values to each project, project popularity can be computed. Students vote on each project with a 1, 2, 3, or a no vote. For a 1 vote, the project is valued by highest by that student, 2 is lower in value, and so on. When viewing the total sum of votes across all students, we can determine the overall value that each project has by the students. This is displayed in a weighted value that the instructor can view and easily interpret which projects were popular with the students, and which may need to be modified to increase popularity in the future. Microsoft Azure definitely had a steep learning curve for all of us. However, we grew as a team during our deployment. In our final implementation, we used the MySQL and web app package to link a MySQL server with a web application hosted by Azure. For the code deployment, we tried to use GitHub to host the code. However, we quickly ran into issues that would lead us to abandoning the platform and moving it to core FTP-LE. The database was the easiest part of our project to host, and this came down to us utilizing the MySQL workbench and Azure built-in Bash console. This can be done from a web browser. However, importing the data to SQL Server is easier done with a purpose-built application. To increase the security of the database, we implemented different permissions for visitors and admins. Visitors can only post new data, while admins can modify and delete existing data. We also added in permissions for the database to communicate with the web app, so that the web application is able to utilize the database to store inputted data, and also to read all of the data submitted when an instructor needs to assign students to projects.
For our database, we utilize MySQL. MySQL is a free and open source database management system that is very stable, as it has been around for many years. It has a big community that helps maintain and debug and upgrade it. And it is very well suited for small to medium projects like ours. The handler.php files are server-side PHP script that holds the credentials, connection details, and handles queries to the database. The script uses the PHP data objects, also known as PDO, as an extension that serves as an interface to connect to the database. In the first part of the script, we have our connection variables with their respective values that correspond to our database credentials. This is how connection was established. To take care of any potential problems in the database queries, you will see the try and catch blocks. The try and catch blocks are exception class. So what they do is if a problem arises while trying to connect, it stops running and attempts to catch and solve the connection error. Before implementing as final product, the connection variables should be moved from the handler.php file to the settings.ini and made inaccessible to the public. Handler.php does not have any sanitation methods yet. This was done by the previous group, so that case you could implement their proven sanitation methods. The algorithm.js uses the Moncrest JavaScript implementation module to utilize the Moncrest algorithm, also known as the Hungarian algorithm, to solve the assignment problem. The algorithm.js calls the Moncrest functions from the Moncrest.js file to outline the assignment problem. Since only one student can complete one project, the Munkres algorithm chooses a single item from each row and column from the matrix to assure that no row and no column are used more than once. The algorithm.js also calls and posts variables to database for later usage. The function.js file is used to essentially make our web page functional. So it's used for loading objects, user side of the web app. It determines what templates and buttons are enabled and disabled. It handles JSON events and other web page functions like get post for template selections and page refresh. It also prompts when errors occur, so if there's not enough projects, missing students' preferences, student assigned to more than one project, then an error will be prompted. And once again, the function.js file just contains all the code that makes the web page work.
The mustache.javascript file was needed to determine what pages needed to be displayed when a certain criteria was met. To do this, it was decided that the usage of a template system will be the most effective. Templates were made instead of separate HTML files for when each criteria is met. To render these templates, we used a JavaScript file called mustache. Mustache.javascript is a logicless template syntax, meaning that it does not solely rely on procedural statements like if, else, and for statements to render data. This template syntax can be uniquely identified by its brackets, which is where this JavaScript file gets its name, seeing that the brackets resemble a pair of mustaches. For our project, mustache global objects are called on the function.javascript file to render the data from the database to the web page. Another plus for using the mustache.javascript, it made rendering and reading code and understanding how the data was being displayed in a web page significantly easier thanks to its template language.
The environment was primarily used on and hosted on Microsoft Azure. One of the benefits of Microsoft Azure is that it can be accessed virtually anywhere. Microsoft Azure also has an array of tools that allows the environment to be scalable, and also offers built-in security as well.
For the web development portion of our project, we have a few different things happening. When several parameters have been met, the web app will display a very basic website pulled from a pre-built HTML and CSS file. This is changed once parameters are met and checked by the function.javascript and algorithm.javascript files. If the checks come back successfully, templates are sent off to the mustache.javascript file to be rendered and displayed on the web page. Though our current setup is configured for our specific project, parameters and templates can be edited later to fulfill whatever task KSU wishes. Next is the website architecture. Our web app has three main pages: the home page, preference page, and the assignment page. All of these pages have a standard KSU like them. Black menu bar, KSU logo, and the black copyright bar at the bottom, and complete with a yellow trim and off gray background. The home page shows very little information. This was done to serve more as a placeholder mixed with an introduction page. Next is the preference page. This is a page for students to fill out their project preferences. It has a drop-down menu for students to select their name from. Once the student's name has been selected, a table will populate with all available projects and a form with a scoring system and a submit button. Lastly is the assignment page. This page is meant for the instructor to assign groups based off of project preferences and given a group size parameters. This page is complete with all the available projects, their respective project sponsors and instructors, along with a weighted popularity score for each project. At the bottom of the table, there's two input fields for the minimum and maximum group sizes, optimize min and max buttons, and the assign, update, reset buttons as well. In regards to testing portion of our project, we followed our own testing plan, focusing on the point of view of a user and professor. We also use information from our current capstone course, such as students and projects, along with the project's respective project sponsors and instructors. For the preference page, we randomly selected data for the preferences, favoring a zigzagging pattern in a completely random order. We tested for the following topics: usability, application function, compatibility with different devices such as desktops and mobile devices, application performance, and data accuracy. Our testing found that the preference selection page had some issues. The preference form would randomly cut off the last few students of the preference page. It would still save the inputs to the database, but would not display them on the actual web page. Next, our project assignment process was not accurate. Again, some students would be completely ignored during the assignment phase, but would still throw an error if they had not filled out their preferences for all available projects. Lastly, we discovered that the reset button would rarely work correctly. This button tended to break the code completely. Once the code broke, we were forced to redeploy our code to the web app instance.
During the testing phase, we found that there were several things that needed to be fixed. After carefully testing the code in connection to the database, we found that there were two things that were giving us issues. First, there was not a stable connection to the database. This was caused by a misconfiguration in the handler.php code that connects the web app to the database. During the deployment, the database connection variables were not initialized properly. This surprisingly still allowed a connection to the database, but caused information to be unreliably pulled and pushed, or the code breaking altogether. To fix this, the database was reconnected by properly initializing the connection variables in handler.php. Next, functions in the code needed to be altered slightly for the usage of a cloud-based deployment solution. These functions were very easy to fix, but the most notorious function that was giving us issues was the refresh page function in the function.javascript file. The timeout variable was originally set to 250 milliseconds. While this would be acceptable for testing locally, we found that changing this variable to 1000 milliseconds fixed a lot of smaller issues in the project due to inadequate time to reliably communicate with the database. Up next, we will demonstrate the web app. When a user visits the website, they will be presented with the home screen. The home screen is blank by design. This is so Kennesaw State University can come in and edit this page with whatever information they would like to be displayed. It can be fitted with a login screen so the web app can determine what pages are available to the users, or any other information that KSU sees fit. Next is the preference page. This page is meant for the students only. When a student visits this page, they will be greeted with a blank table and a drop-down menu. The student must first select their name from the drop-down menu for the projects to populate in the table below. This drop-down menu can be removed and replaced with a login option so students can't vote on their peers' behalf. Once this is done, the student must then select their preferences for every project available. Failure to do so will create issues for the instructor. Luckily, the web app will tell the instructor who hasn't completed their project preferences during the assignment phase. Students will notice that there are 4 options to select from for each project. This is for their first, second, and third choices of projects. The N option is for projects the student isn't interested in. These options are important for the assignment process as they serve as a popularity guide and will be used in the Munker's selection algorithm. Once the student has filled out their preferences, they would then need to click the Submit button to save the changes to the database. Students can change their preferences by selecting their name from the drop-down menu and making the change. The last page is the assignment page. This page is meant for the instructors only. Once the instructor visits this page, they will be greeted with a fully populated table complete with the available projects, their respective sponsors and instructors, and the project's respective weights. The weights are a numerical representation of the popularity based off the student's preference selections. At the bottom of the table, there are the project selection controls. The instructor will first put in a desired minimum group size in the field labeled minimum, and the largest desired group size in the field labeled maximum. Next, the instructor can choose to either optimize the selection process by the minimum or maximum group size by clicking their respective button. The groups will then be selected using the Munkers algorithm and the instructor's provided group size variables. The instructor will then need to click the Assign button to save the changes to the database. The instructor can change the group members by clicking the student's name and selecting the desired student to be switched with. Then clicking the Update button. The instructor can also click the Reset button to restart the selection process with different group sizes. Do keep in mind that this only resets the project selections and not the student preferences. There are a few common errors that show up using this web app. The first error is the application will throw an error if a student has not filled out their project preferences. This error will show up as a pop-up on the instructor's assignment page. The web app will tell the instructor exactly who has not filled out their project preferences by pressing F12. To solve this, every student must fill out preferences for all available projects. The next error is not enough projects to support the amount of students in the class. This error will also appear as a pop-up on the instructor's assignment page. To solve this, more projects will need to be added, or the group size parameters need to be adjusted. The last problem is a compatibility issue. This project will not work on Microsoft Internet Explorer. Explorer lacks support for ES6 compliant JavaScript. This project will work with Microsoft Edge, Mozilla Firefox, and Google Chrome. We faced many challenges during this project. We found that Microsoft Azure has a rather steep learning curve and is not beginner-friendly. Luckily, there is a lot of information regarding how to use Azure and what can and cannot be done with this program. As mentioned earlier, we faced database connection issues. This was mainly due to multiple contradicting resources regarding this process. We later figured out the correct way of getting the database to connect with the web app and communicate reliably. Lastly, we had one team member have issues with their Microsoft student account supplied by Kennesaw State University. To combat this issue, we shared accounts with our teammate. This issue was later solved with the help of KSU's IT department and Microsoft's support team. Overall, this project was a success. Our group displayed amazing teamwork throughout the project, even throughout all the challenges. Our project sponsor was very happy with the outcome of the project as well. To quote our project sponsor, Dr. Shirley Tian, "I am so impressed with this group's teamwork. This project needed a lot of effort to figure out how to implement the algorithm to sort out the project assignment from students' preferences. They not only performed the algorithm, but also moved the project to the Azure cloud platform. All of these are significant steps for the project, sponsored to move this project forward to a fully functional website.